Hello and welcome to Frequency Response of an Amplifier tutorial. In order how to do frequency response analysis of a filter, please refer to Introduction to Pspice tutorial AC sweep section. Let's build the circuit shown. For our Mosfet transistor, we will use Ampfreqresp model. It's right over here already selected, so hit OK. And we'll put it right over here. Since demo version of Pspice doesn't have Mosfet transistor, we have to simulate it using go ahead and click Edit Pspice Model, and we'll use right here Kp equals to 0.1 e to negative 3. Our W gonna be equal to 10U. Our length is gonna be 1U, and our threshold voltage will be 1.5 volts. Let's save it. For our source, we will use VAC. Let's create a new simulation profile. Our starting frequency will be 1 Hz. And ending frequency will be 10 megahertz. Remember to put meg. And points per decade, we're going to be on a logarithmic scale, will be 10. Let's choose a marker and put it right over here on the output. Let's run Pspice. Right here we can see that our gain in the midband right here is 3.9 because we use 1 volt as an input. Let's now delete our plot. We just highlight it right over here and hit delete, and we'll just go and add trace, and we'll choose decibel. And we'll put VC12 right over here. That was our output. Alright, now we got a decibel scale, logarithmic scale. Right here we can see the decibel value of our gain is 11.8, which is 3.9. Another way to do decibel graph in decibels, we can just go ahead and delete this marker and go to Pspice markers. We choose the advanced markers and we put decibel magnitude of the voltage. So now we can run Pspice and we'll see exactly the same graph. But note that this marker right over here, the advanced decibel magnitude of voltage, only available if you have an AC sweep analysis. It will be not available, all these markers will be not available in transient analysis, for example. Let's determine our cutoff frequency. It will be right over here 8.8 decibels. So we can go right over here. So 11.8 minus 3 decibels, it will be 8.8. So, and we're close by right over here. That's going to be our cutoff frequency. And we can see it right here. And our frequency is 1.35 approximately. You can also notice as our frequency is increasing, our gain stays the same, which is unrealistic, and the reason is because we're using incomplete model of our transistor. Later on we will adjust capacitance and we'll include it in our model. Let's go ahead and change the capacitor values. Now let's change the input capacitor to 1 microfarad. And rerun our Pspice. Now we can see that our low frequency 3 decibel point moved actually, and now it's 8.8 will be at about 6.7 frequency. Now let's go ahead and change another capacitor. Let's change this capacitor to 1U. Okay, now we can see that our low frequency point of 3 decibels has moved to about 10.8 hertz. Let's go ahead and put 0.1 microfarad. We'll keep decreasing our simulation, our value of the capacitor. Right here we can see that our 8.8 point is at 100 hertz, so we moved it even further apart, so it went increased by the factor of 10, if you can see it. So it was 1, it was 10, and now it's 106. Now let's simulate the internal capacitance of the Mosfet. And we'll include CGSO and CGDO. Note that the CGSO and CGDO are not equivalent to CGS and CGD. Just hit save. And we change our simulation to 1 gigahertz. And we'll extend our band. Now let's measure high frequency 3 decibel point. It is about at 220 megahertz, and our low frequency corner, 3 decibel corner, is about at 106 hertz. Let's rebuild our circuit as shown, and if you can notice, this is the circuit that we used for transient analysis of BJT amplifier. And for our amplifier, we will use the Q break and model. Let's edit our Pspice model. just put BF100 for our beta. IS equals to 1E negative 15 for our saturation current. CJC will be equals to 4 pico, and CJE equals to 5 pico. Note that although CJC and CJE represent internal BJT capacitances, they are not equivalent to CP and CMU. The computed values of these parameters are shown in the Pspice output file. Let's save our model. Let's set up our AC analysis to run from 10 Hz to 1 GHz, and we'll do simulation. Alright, now we can see that our gain is approximately 8.7, and our lower 3 decibel corner is about 41 Hz, 41.5, and our higher 3 decibel corner is about 79 megahertz. Now you can change different values for external capacitors and see how they affect the lower 3 decibel cutoff frequency of the amplifier. And this will conclude our tutorial. Thank you.